Okay, let's start with a wrap-up session. We want the executive committee members of the GFRA to be here. So Nagendra, Anna, Mariano, the executive committee members, please come on stage.
I think Poster is here as well.
Okay.
On stage with Tommy. Yeah, well, I want everyone to know who you are.
We were
Don't kill
kind of
yourself.
talking about key points
Okay.
from our session. Do you have?
And we are missing Toby, I think.
What do I need to add? I'll just add on to whatever you say if there's anything to say.
¿Por qué
I'll
se van?
probably just be similar. I mean, to be honest.
Ah,
When the people left, we're going to have a lot to drink.
there's one.
We got one more in the.
No, there's one in the.
I can
Toby.
stand here. Here is Toby. We're waiting for you. Okay. Okay.
Did I take your seat now?
It doesn't.
That's for Linge.
Okay. Okay, let's move to the wrap-up session. This is the almost all the executive committee. We are only missing two, Fedra and Frank.
Yes.
So, well, for you to know the faces. So we are going to summarize what we have been discussing. So we're going to start with the first session. Why should we control FMD? And I think that Wilna is going to give us a short abstract of what we discussed.
A very short abstract,
Yeah.
yes. So, yeah, it was really very interesting, I thought, this morning to hear about the foot-and-mouth disease situation in different parts of the world. And the big question that came up, can we take lessons learned from one region and just directly extrapolate to another? And my impression from the discussion was that yes, but with big caveats that you need to make very big adjustments. Where one region, as was so well pointed out by Nagendra, have a very similar language and culture, and in other regions, that is not always the case. And how do we, as scientists, try and address this? And I think it was a theme that's also come out quite a lot along the conference, is the need to involve our social scientists in the work that we do. Make sure that they are part of the research projects that we plan. They should potentially also be brought in a lot more when policy is designed, and sort of from the bottom to the top, where you look at how, what can we do to make farmers report disease, right up to what can we do to help the politicians make the right decisions. Another point that I took out of this, the morning session, was the narrative that we as scientists use as well. We tend to focus quite a lot on the technical issues, the sort of the direct issues that impact us and the livestock industries, but we don't always link that broader. As Keith pointed out, how do we link disease control and foot-and-mouth disease control to other very important and very pertinent challenges that we are being faced, such as climate change, the emissions, etc., and antibiotic resistance. And how do we link those narratives to build our case for better disease control? Another point that came out that again links a little bit more to the social scientists or sciences is the value that these animals have in certain cultures. And we don't always consider the fact that a disease control option such as culling could have an enormous impact on a society and can actually have impacts on a child's education or a celebration taking place. And certainly very important things that we need to consider when we design our research and when we communicate with the policymakers. Let me just see, what else did I write down? Of course, something that I also pointed out is just working again with economists in terms of trying to understand the market drivers a bit better, because that also plays an incredibly important role in how we control the disease and where do we focus our efforts. So these are just sort of the very broad aspects, and I'd like to first maybe open it up to our panel members if you want to add anything before we open it up to the floor.
The need of vaccination that you were I can take this one. Oh. On my own. No, perhaps we also discussed why stopping vaccination.
That's true.
That in some, that was a very interesting discussion, in fact, that in some countries vaccination is considered like an insurance, and if there is a real need due to commerce and to stop vaccination, if that is the real final goal. I think that was a very interesting discussion. I haven't heard that much before.
I agree, and what the question that came up in my mind was the cost of the vaccination campaigns. How much does that play a role in the decision to stop vaccination versus the risk of a reintroduction? And I don't think that's a point that we really discussed this morning, is actually just that cost of the vaccines and the vaccination campaigns. We did speak a little bit about the loss of contact with animals if you do lose your twice-a-year contact with animals. But that twice-a-year contact with animals also comes at a cost. And I'm not sure if anybody has done that cost-benefit analysis in terms of what would happen once you stop vaccination. So anybody else in the panel?
A very good point that the cost of vaccination is extremely high, which a lot of people do not realize. In the Netherlands, when we vaccinated, we paid our vets 7.5 guilder, that's 3.4 or 5 euro per cow, and that is much higher than the cost of vaccine. And stopping vaccination in Europe was also based on economics. They just looked at how many outbreaks can we have to break even, and it was 2 outbreaks a year in the next in the period of 1991 to 2001, and we only had 4, so we made a lot of money.
Any other comment or anything else?
There's one
Okay.
in the back.
I mean, just concerning your question about what other effect it has when you stop vaccination, we had with the Task Forum a conference in summer this year in Argentina with South American countries, and it came up as well that, since they don't have the contact anymore, the other vaccination schemes are also not anymore conducted. So because it's not worthwhile to bring the animals together and vaccinate them for helmets or other stuff, So that's one thing. And so you see other clinical manifestation at slaughter afterwards, which you didn't have when you see the animals twice a year.
So it's maybe something that we can encourage in countries in South America once they start stopping vaccination, to look at the impacts and make the rest of the world aware of that.
No, I think in that respect is critical to what are the assumptions that you are taking in terms of the potential outbreaks, how frequent they could be and from where, that would change the math of this balance very much, because if it is something that happens once every 500 years is one thing, and the other is that probably you have chances to have an outbreak in 2 years. So that's something that, to me, it's not that easy to predict. I mean, you can say, well, if you didn't have any outbreaks for 15 years, probably you won't have any more. I don't know. So to me, that's a big question that will impact on this kind of calculations that are critical, of course. Sure.
And of course, we are losing capability because many of the vaccine manufacturers have closed now, which means that there are fewer in the world. Just the final point that I would like to raise from that session was also the mention of having breeds that are more resistant to disease. Of course, that is something that I think there are research groups working on, but more in terms of making genetically modified animals that might be more disease resistant. And that's, of course, a whole topic of discussion in terms of the regulations around that and how that may impact in sort of livestock farming in the future. But a very important point that could be very pertinent to endemic countries where that could help with alleviating the impact. First, just looking at the naturally more resistant breeds, and for the research environment to learn more about these animals and looking what makes them more resistant. And quite often I've asked the question myself, and I've heard other people ask it, are they truly more resistant? Do we know enough about those breeds to know that they are indeed more resistant, or are they just more resistant to certain strains and not others? A whole area of research that I'm not sure that we always look at in enough depth.
In addition to that I also learned for the first time today is though that an immune system is not free, and the question was also raised, yes, they may be resistant to FMD, but if that comes at the price of an overall reduced productivity, you may not actually gain as much by the resistance than you were hoping for in terms of still feeding your population.
That's right, yeah.
Okay, so does anyone have anything else to say? Otherwise, we can consider this is summarized and wrapped up. There's something else. Okay. Abu Bakr.
Yeah, thank you. Just for us not to forget too, that we discussed something very important on the possibility of deploying LFDs to endemic LMICs.
Yes, so let's move on to the second session then with that point. I'm just going to start summarizing some of the things that stuck out to me, and then I'll ask Anna to just fill in. On the topic of LFDs, I mean, we did hear different opinions about it. Are they a net positive or not, and in what situations? What I think is that a lot of the resistance, at least in free countries, comes back to the question of sensitivity and the false negatives, etc. And I then had discussions with other people in the audience about, well, we can make more sensitive LFDs. We have learned, for example, from COVID, again, that over the course of the outbreak, the LFDs did become better, and some of the lessons that were learned from that could maybe also be applied to FMD LFDs. At the same time, that doesn't remove the other concern about, like, who do you want to give the power of a diagnostic test to? Do you really want to have that power in the hand of the farmer, or is that something that the official veterinary services, be it in a free country or in an endemic country, would rather keep in their own hands? And then Keith's comment comes to mind, or one of his comments comes to mind, where he said, well, you're all talking about LFDs, we should talk about some of the other things that are out there, some of the other progress that has been made, and one of that is the environmental sampling, which I think addresses a lot of these concerns, because then if you're not sampling a farmer's animal, but you're just sampling a market, or you're sampling a trough or a watering hole or something else, maybe with a more sensitive LFD, you still get the same information. You still get an insight into what is going on in the area, and at the same time removing some of these conflicts of interest that come from sampling somebody's property, somebody's livestock directly. And at the same time, that may also be a step towards addressing another big gap that came up at several points during this conference, going right back to Don's presentation at the very beginning, with this idea or this observation of the very sparse and very fragmented surveillance, where we obviously have large gaps in what we know about the viruses that are circulating, where you have viruses disappearing for 40 years, then reappearing out of nowhere, and possibly in wildlife reservoirs that are not being looked at, etc. But maybe that is also something that environmental sampling with highly sensitive tests can address better than trying to chase down every last buffalo and getting a sample from the animal itself.
Maybe just to add from that, and maybe also because I guess we've had a bit of time to reflect on that section as well. I mean, I think in that section we kind of went around in a lot of circles, and there was a lot of attention spent on, LFDs and some of this technology, when actually we know that there's also new technologies as well. And I, on reflection, I'm just wondering if maybe that session we should have actually kind of addressed slightly differently, in starting with maybe the endemic countries and with the free countries, and saying, well, what questions do you have, and what are the problems that you're facing in the field, and then try to figure out what diagnostic tests we could to address some of those gaps. And if there aren't those diagnostic tests, or there are diagnostic tests that maybe don't have the sensitivity and the specificity, what can we do as a community to increase those areas in research? Because I think there was a lot of questions, LFDs, do we use them here, do we use them there, do we do them, how do we use them? And I think it's actually quite important to have that understanding first. Where are they going to be used? How are they, what information do you hope to gain from them? And really work through it more that way to then see where the gaps are. But is there anything else in the audience?
Or does anybody want to address that very question that Anna just posed?
Sorry. I understand it's getting quite late in the day on the third day, but.
Yeah.
Lahendra?
So, so what do we have now in the field? We don't have anything. We are totally dependent on the staff to collect the samples and send it to the labs. 50% gets identified, 50% is not identified. And as one of the studies said, that LFDs are equivalent to your antigen ELISA. So we are not losing anything in the field. But still we are having something that is sent from the field to the lab for a characterization. And I understand all the intricacies in this, but let us identify the people whom we trust and hand over those devices. It need not be the farmer, but it can be a field veterinary staff whom we are going to trust with the animal's life. So please consider those aspects as well. Yep, thanks.
Okay, if there's nothing else to add to
I
that.
have one little
Yeah.
non-controversial point, I think, and nothing that I did learn. Loic mentioned that it would be helpful. I mean, this is only about Europe, but it's a starting point, and to similar to what we have on the vaccine field, where you have this mutual recognition within the European Union. That is same thing is lacking from diagnostic tests. So the manufacturers then have to think again and again for every single country, is it really worth it for me to spend the money to get a marketing license in that country? How much of my test am I going to sell? And some more harmonization in that area would maybe remove some of the barriers for manufacturers to actually bring innovative concepts to market. That was the one thing that I still had on my list.
We have a comment.
Just a comment on the LFDs and sensitivity based on some lunchtime conversations about they're kind of hard to apply in the field because they depend on sample processing. It might be worth testing other sample types. Like we have freezers full of swabs that we have characterized by PCR and or VI, and there might be some relevance in actually doing some testing. Could you use a swab sample? And we're talking about small ruminants that might not have vesicles. Mm-hmm. Could you use a different kind of material that's easier to get? I mean, people are COVID swabbing themselves. If they could take a swab from an animal and do an LFD, that would be a lot easier. And assuming that the LFDs we have now might have a better sensitivity than those we started out with, then it might be something worth considering.
Any other comment? Okay, then we are going to summarize the last session that was control of FMD using novel vaccines. Toby?
Okay, so I'm not a vaccine expert, but I'm going to try and summarize this session. So I'm going to go back to the questions I tried to pose at the beginning. So the first one of these was, do we need new vaccine technologies? So the answer to this is not completely clear to me. I mean, it is clear that new technologies could offer advantages. I mean, the obvious one is a more thermally stable vaccine. That's an obvious advantage, and that's potentially already in the pipeline. The other obvious one is duration of immunity. And as Keith pointed out, we don't actually know what it is we're looking for. Where are the goalposts for duration of immunity? So that's a huge gap, I think, in our understanding of, you know, everyone talks about how a live attenuated vaccine should give a better duration of immunity, but nobody knows. Nobody knows what the duration of immunity should be, even from the optimal situation of a natural infection. So for me, that's a massive gap. And then on the other side of the coin, perhaps we just need to make sure that all of the conventional vaccines that we make globally are up to a certain standard, and then maybe that would do the job. Maybe that's enough. Maybe we don't need new technologies. You know, it's not clear to me where we have these discussions every few years, and I don't know if we ever really reach a decision. But we don't need a decision. It's just a discussion. But it's still a debate. Okay, it's just an ongoing thing. Okay, so another question asked was, what are the drivers for industry to invest in new technology? And I think the answer to this is that industry is investing in new technology. You're trying new stuff all the time, but it's difficult, it's expensive, and it takes a long time. So one thing we could say in response to that was, how can the global research community work with you to try and de-risk some of this stuff? You know, how can researchers help? If there's a clear need or an advantage to trying a new technology, how can research be part of that to help the industrial component? And then, I mean, we talked about the regulatory hurdles. And on the one hand, anything is possible, is what we've heard today. You know, in previous discussions, there's been an argument that a live attenuated vaccine for FMD is never going to be possible. It's just, don't even think about considering it. Today we've heard, well, why not? There's nothing to stop you doing it. You just need to go through the right process. But then on the other hand, we hear that it's already very difficult even to register a new conventional vaccine. Okay, it's a lot of work, it's a lot of time, it's a lot of investment. So again, no real clear answer. Anything's possible, but it's just a huge hurdle and a huge piece of work. So yeah, I think we've still got quite a long way to go.
Yeah, and I think that the research gap we identify every single year that we get together and we look for research gaps is immunology. So immunology in the species we are working with, but particularly in cattle, we really don't know how the memory is established. There are many aspects of the basic immunology that is not even addressed. Is there anything else that we missed on that discussion with no answers questions that we got? Because, yeah.
I just wanted to make a comment. I do agree on the points that were mentioned related to the duration of immunity. And this is very challenging when we are working with experimental animals. We only have the capacity for holding the animal rooms for a certain period of time. So testing duration of immunity can be challenging. And like it was discussed, we also don't have the right parameters for determining that. I think collaborations with other institutions that perhaps can provide us that support to do long-term studies with some of our live attenuated vaccines will be ideal.
I have a quick comment on the duration of immunity. I remember Keith prefacing his statement with a different statement, though, where he just said, well, it's about a literature search. That information, the duration of immunity after natural infection, may already be out there. There may be really great papers from, I don't know, the 1950s, 1960s that we've all forgotten about, where this question has been addressed. And back then it was easier to keep animals alive for longer, and there were infected animals out in the field in countries that were getting rid of FMD and were being able to maybe follow these animals for a while. So maybe as a piece of homework until the next open session, go back to your libraries at your various institutions and see if you can find a paper or two about the duration of immunity after FMD infection.
That's your specialty, Michael, or the old papers. So the last section was on control of FMD using novel vaccines. I was actually a little disappointed that so much time was spent talking about live attenuated vaccines, because as a self-described virologist, I don't really consider live attenuated vaccines novel or new technology. I think they're quite old-fashioned. And I was hoping to hear some really unique new ideas on real new tech. But perhaps considering that we've heard the value of endemic countries making their own vaccines, and then we've also heard from Danny that the current FMD vaccines are actually quite complicated and difficult to produce well. New technologies perhaps should also be considering to aim for a simpler process so that it's easier to make good quality vaccines, and then we might end up with less poor quality vaccines. But of course, in the interim, we should definitely be focusing on assisting the smaller manufacturers and assisting the less developed regulatory authorities at being able to focus on making sure there's good quality, which of course is some of the objectives of the wonderful pre-qualification of vaccines project we're doing at EUFMD. So, thank you.
Thank you. Just a quick one. I think what we discussed about the live attenuated vaccine, especially what Medina presented, is quite novel and is quite new, because when you de-optimize, especially some codons, to bring in something novel. And I really appreciate what she and her partners have done. And I must say that we are also open to partnering with you in any field experimentation.
Something about the immunology.
Yes.
So we have been very much cattle focused in our FMD vaccines. It's all cattle focused, but in Southeast Asia, Asia, and in Africa, yes, cattle are the major thing that we see as affected and those things. But these little ones running around within the cattle herds are the ones that are doing all those stuffs, the small ruminants. We just say half the dose of cattle is enough for small ruminants. Do we have proof? Have we done proper antigenic study in small ruminant to say, is this the antigen payload required for sheep and goat? When we had the formalin aqueous vaccine, we had 3 ml. Then we said 1/3 of the cattle dose is sheep dose without any studies. Then we had the oil vaccines, 2 ml. We can't make 1/3 of 2 ml, so let's say 1 ml. So if we actually do some studies for cattle and sheep, say this is the antigen payload required for cattle and sheep, and this is the dose volume required, we can have a targeted market for you. Why don't we think on those aspects? Cattle are there, but we don't know anything about the immune responses in sheep. We need to invest on that as well, as a researcher. Thank you.
Thank you. If there's no more comment, I will just close the session. Before, I want to thank our generous sponsors, Boehringer Ingelheim, MSD, Biogenesis Vago, and CTV. Thank you so much. And as I said at the beginning, we have a cocktail hour, so hour and a half. So it starts, okay. No, but it doesn't matter. It's 5:30, and I go all the way around. That's not gonna happen. Okay, it's 5:30, but it's not in the garden where we were having tea or whatever. It's in the patio right beside the place where we had lunch. So there, we wait for you there for a cocktail, and well, we hope you enjoyed the discussion. Maybe this is not the first time we are going to do these kind of things, hopefully. And thank you for your cooperation. Thank you for your insights. It was quite exciting. So thank you so much. And thank you all the executive committee of the GFRA for a very hard work. And this closes everything, the UFMD, the GFRA.
Also, Toby has determined that this is not, in fact, his cable. So it's still up for grabs.